Assalamu alaikum guys, welcome back. Okay, so now in this lecture we are gonna do ionic bonding. In the previous lecture we completed covalent bonding, alhamdulillah. Okay, in the previous, like, it took around 5 to 6 lectures to complete the entire covalent bonding portion, but now we are gonna start out ionic bonding, and this is relatively less than the covalent bonding because covalent bonding included the simple molecular, giant molecular, and the intermolecular forces were also included in between that chapter. So yeah, it took us a long like a few videos to complete covalent bonding. Now it's ionic bonding that we are starting, so let's begin. All right, so ionic bonding, from your O levels you already know what that is. The definition is exactly the same, there is no difference in here. Okay, so what are ionic bonds? These are actually strong electrostatic forces of attraction formed between a positive cation and a negative anion. Okay, I hope you guys know what cation and anion is. Anion is a negatively charged particle and a cation is a positively charged particle. Now over here, how are ionic bonds made? Ionic bonds are actually made by the transfer of electrons between two species or two atoms, okay, resulting in the formation of ions. Okay, in covalent bonding there was sharing of electrons. In ionic bonding there is transfer of electrons. The transfer is always from the less electronegative towards the more electronegative element. Okay, because of course you guys know that the more electronegative element wants to attract the electrons towards itself, right? So that's the concept. Now let's get to the definition and complete this portion. Okay, so it's a transfer of electrons that forms the ionic bonding. Okay, and the definition is these are the electrostatic forces of attraction between positive cations and the negative anions, and that's it. Okay, if you are asked to define ionic bonds, well, generally the examiner doesn't ask the definition of ionic bonds because it's already covered in O levels in such a detail that there is no use of defining ionic bonds again, but still this is a definition in case an examiner asks you the question. Then coming to sodium chloride and magnesium oxide as the classical examples of ionic compounds. Okay, these are the two ionic compounds that we have, the classical examples of ionic compounds that we have. We'll be doing a lot more detail, the period 3 elements, later on when we'll be doing the inorganic chemistry. But over here, these are the two examples on which I have seen like many questions asked on the past papers. Quite frequent questions have been asked regarding their structures, regarding their melting and boiling points, regarding their trends, etc. So let's get started with these. Okay, so both of them are ionic compounds, but if you are asked to describe the structure of either sodium chloride or magnesium oxide, how are you gonna do that? Well, sodium chloride and magnesium oxide, they are both giant ionic compounds, or they have a giant ionic lattice. Okay, these are the key terms. This is the key term that you are supposed to include in your answer in order to get the full marks. What is the structure of sodium chloride and magnesium oxide? They have a giant ionic lattice. And why do they have high melting and boiling points? They have high melting and boiling points not because of intermolecular forces, not because of the covalent bonds, but rather because of the giant ionic lattice and the ionic bonds, the thousands of ionic bonds that they contain as well. This is called giant because they also have like many ionic bonds included inside of them. Okay, now so many strong ionic bonds are there. These ionic bonds have to be broken in order to melt them down or in order to boil them off. Okay, so of course, well, boiling is generally not included in the syllabus because boiling would require quite a lot of temperature, but it's the melting that generally the examiner would ask you. Okay, so both of them have high melting and boiling points. A very common question regarding magnesium oxide that is tested on the past papers is that the examiner tells you in the question that magnesium oxide actually has a high melting point. Okay, it has a high melting point, and you have to explain, or you have to give, or you have to suggest use of magnesium oxide. Okay, so the common use of magnesium oxide due to its high melting point or high boiling point, high melting point, is that it can be used to line furnaces. Okay, the furnaces which are used for baking bricks. Okay, they have like a high temperature, very high temperature of around 2000 degrees Celsius. and the melting point of magnesium oxide is up slightly above that, so it can be used to resist that high temperature in the furnaces. Okay, similarly refractory bricks can also be made using magnesium oxide. I would want you guys to learn these uses. Okay, these uses must be learned very nicely because this is a very important portion of your exams. The magnesium oxide is used as a refractory material and it is used for lining furnaces. Then coming to the structure of sodium chloride, which is your common table salt, right? It is formed by the transfer of one electron from sodium to chlorine, whereas in case of magnesium oxide, there is a transfer of 2 electrons from one magnesium atom to one oxygen atom. Okay, so due to this reason, magnesium oxide actually has stronger ionic bonds. Okay, stronger ionic bonds as compared to sodium chloride. If the ionic bonds in magnesium oxide are stronger than sodium chloride, that means that the melting point of magnesium oxide is actually higher than the melting point of sodium chloride, because more energy would be needed to overcome these ionic bonds. And this is a question that has been asked as well, the comparison between the melting points of these two compounds as well. But again, this is going to be covered in a lot more detail in inorganic chemistry as well. Now going on to the structure of sodium chloride. In case of sodium chloride, every sodium atom is bonded to 6 chloride ions. How 6? Well, if you look at the structure over here, you've got a sodium ion, right? Sodium ion is in here. It is bonded to chloride ion on the left, on the right, on top and at the bottom. But guys, remember, this is not a two-dimensional structure. This is a three-dimensional structure. Three-dimensional means that there must be a chloride ion on top of sodium and behind sodium as well. Okay, so 6 meaning each sodium is bonded to 6 chloride ions. Okay, remember that. And each chloride on the other hand is also bonded to 6 sodium ions. This is something that might have been explained in your O-levels, but some of the students, they don't actually get the reason, while some teachers actually don't consider it as important to be taught in O-levels, because it's not actually a part of O-levels, it's actually a part of A-levels. So that's why it's better to revise this concept, that each sodium is bonded by ionic bonds with 6 chloride ions, and each chloride is bonded by ionic bonds with 6 sodium ions. And this is the structure, how it is made after transfer of electron from sodium to chloride. If you are asked to draw out the dot and cross diagram of sodium chloride, you are supposed to show the outer shell electrons only. It's the sodium that has lost its electron and formed and completed its octet, right? Meaning its outermost electron. There was just one outermost electron in case of sodium, right? So it lost that electron, and the 8 electrons are left in its outermost shell. Whereas in case of chloride, the chloride actually accepted that electron from the sodium, and as a result, that electron is also shown over here. Okay, the crosses represent the electrons of sodium and the dots represent the electron of chloride. Since chloride accepted 1 electron from sodium, therefore I have shown that electron to be a cross. Okay, and of course their charges have to be mentioned, and it is assumed that yeah, they have electrostatic forces because of their opposite charges. Now coming to the last portion of this video, which actually finishes off this chapter, starts and finishes off as well, it's this portion. Okay, this point is very important, again heavily tested in the past papers. When do the ionic compounds, they conduct electricity, and why? This is also a question that was included in O-levels as well, so most of you might know the answer to it. Reason, why do ionic compounds conduct electrons? Why does something conduct electricity? Sorry, not electrons. Why does something conduct electricity? Actually, electricity is conducted due to 2 particles. First of all, due to a certain particle. What sort of particle? Delocalized particles. Particles which can move around. Which particles? It's the charges that conduct electricity. Okay, what is electricity, by the way? Electricity by definition is just the flow of charge. Okay, the charges can be electrons, they can be ions. These are the 2 different types of particles that you have. Okay, in case of metals, electricity is conducted by electrons. In case of ionic compounds, electricity is conducted by ions. But remember, the electrons or the ions, they must be free and they must be delocalized. Okay, free and delocalized, same thing. Or they must be mobile. If they are free and mobile to move, only then will they be able to conduct the electricity. Only then will they be able to flow in order to conduct the electricity. So this ionic compounds, they only conduct electricity when they are either dissolved in water, that is they are in the aqueous state, or when they are in the molten state. In both the states, the ionic bonds are actually broken down, or if not broken, the ions are actually free to move. Okay, in aqueous state and in molten state, the ionic compounds, they are free to move. The ions are free to move, and if they are free to move, then they can conduct electricity. Okay, but remember, if the reason is asked that why are they able to conduct electricity, it's actually the ions. Okay, the ions that allow these compounds to conduct electricity, it's not the electrons. And this completes ionic compounds and ionic bonds. If you are asked to, so just a quick recap, if you are asked to describe the structure of ionic compounds, they have a giant ionic lattice. Why do they have high melting and boiling point? Because of the giant ionic lattice and the many ionic bonds they have, and lots of energy would be needed to overcome them. Why does magnesium oxide is used? Why is magnesium oxide used as a refractory material or to land furnaces? Because of its high melting point due to its giant ionic lattice again. And lastly, why do they conduct electricity? They can only conduct electricity in molten or aqueous state, and the reason why they conduct is because of the delocalized ions or the free ions they contain, not the electrons. Okay. In the next video, we're going to talk about the metals. Thank you.